Hello everyone, today let's solve the problem robbers what. So this was asked in the Codeforces around 359 for the division 1, right? So what the question states here, so you can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem, right? So just give me a second, 1 second here, just 1 second. Yeah, so robbers use base 7 watches. Again, I'm telling robbers use base 7 watches, right? Robbers in the sense thieves, right? Robbers use base 7 watches, hours that go from 0 to this one, n minus 1, hours that goes from 0 to n minus 1. And one more thing, minutes that goes from 0 to m minus 1. Same thing, 0 to, this is not this one, 0 to m minus 1, right? So this is fine. Robbers use base 7 watches, hours go from 0 to n minus 1, minutes from 0 to m minus 1. This is main thing. Hours section has minimal base 7 width, right? So hours section has minimal base 7 width to represent n minus 1, right? So hours section, I'll just give you HS, right? Hours section has the minimal base 7 width to represent n minus 1, and the minute section similarly for m minus 1, right? So minute section similar for this one, m minus 1, right? So here hour section has minimal base width 7 width to represent n minus 1, and the minute section similarly for m minus 1, right? So main thing here is we need to count the pairs of basically hours and minutes, right? So we need to count the pairs of hours and minute. Basically, I'll just write here min. So this is fine. Min is not minimum. This is minute. I'll just write here minu, right? So this is fine. MINU. So we have to count the pairs, nothing but hour comma minute, whose base 7 digits are all distinct. So all the base 7 digits should be distinct, right? So we have to count them in the pairs, hour comma minute. So that's what we need to do. Simple, right? So again, robbers use base 7 watches. Base 7, when I say this one, this part, when I say base 7, hours go from 0 to n minus 1, and minutes go from 0 to m minus 1, right? So, and basically n and m, they have to provide in the input, right, accordingly with the question. Let's see the input output part later, man, right? So this is fine. Hours section has the minimal base 7 width to represent n minus 1. Minute section similarly for m minus 1. This one, hours section as well as the minute section, right? So they has the minimal base 7 width just to represent n minus 1 and m minus 1 respectively, hour section and the minute section, right? So what we need to do, we need to count the pairs here in the form of hours and minutes, right? Whose base 7 digits are all distinct, are all distinct. When I say they're all distinct, right? So just keep this in mind. Simple, simple, right? So this is it for the this one problem. Basically, let me come to the input output part, right? So let me delete this one. Yeah, see here we have been given n, and this is nothing but n, this one 2, and this 3 is nothing but m, right? So n and m we got here. So the output that we need to get here is 4. So the output that we need to get here is 4, right? So this is fine. The output that we need to get here is 4, and n and m we have been given 2 3. Output in the sense the pairs whose base 7 digits are all distinct are 4 here in this case, right? Same goes with this one as well. N and m we have been given 2, and the pairs whose base 7 digits are all distinct here in this case is 5, right? So I hope this one is completely clear. Let me input output part is completely clear along with the question. So let's do one thing. Let's discuss the approach followed by the complexities, and then let's write the code as usual, right? So now let me tell you one thing. I'll consider the first one, this one, right? So for the approach, just for the approach sake. So you can do the same thing for the example 2, example 2 or the input 2, right? So so let's consider the first example for the approach. You can do the same thing by considering the example 2. I insist you to try out for the example 2 in the same way that I show for the example 2, man, right? So that you understand the problem better, right? So this is fine. Let me delete this one. As we are completely familiar with the question and the this one input output part, let's go with the approach followed by the complexities, right? So as usual, let's go with the approach first. So I have considered the same first example that they have given in the question, right? So 2, 3, this is nothing but 2 is nothing but n, and this is nothing but the m. The output that we need to get here is 4, the pairs, right? So this is fine. Let's move on with the, so before moving on with the step-by-step explanation, so let me tell you one thing. We'll be making use of the dynamic programming along with the DFS, right? So we'll be going with the dynamic program along with the DFS, right? So just keep this in mind. So let me go with the step-by-step explanation here. So n we have been given 2 and m we have been given 3, right? So in the input, the first line, n we have been given 2 and m we have been given 3. First we have to calculate the this one, minimal base sum and length, right? So length h, so here I am giving digits of 1, right? So length h is nothing but the digits of 1. So this, the value is 1, because we are computing the minimal base sum and length, right? So length m also, here in this case, digits of 2, this is nothing but the digits of 1 and this is nothing but the digits of 2, right? So this n we have 2, so we have to consider 1 and 2 both, right? So total length we have here is 2, both are 1, right? So total length we have here is 2. This is fine. Now we need to build the limits array. Nothing but build the limits array will be going with the digits n and digits m, same similar to this one, right? So this is length and we are building the limits array, so I have considered digits nothing but digs, digits n and digits m, right? So this one is 1 and this one is 2, we know that one, right? So because n we have been given 2, we have to consider 1 and we have to consider 2, right? So now what we will do, we will enumerate all the higher minute pairs on base 7. What we're gonna do here, we will be enumerating all harmonic pairs in the base 7 hairs, right? So here hairs 0 comma 1, minutes is 0 comma 1 comma 2, right? So basically we have 1 and we have 2 for we have to enumerate all our minute pairs in the base 7, in the sense we will be considering from 0. So this one will be for the 1 0 comma 1, for the 2 it will be 0 comma 1 comma 2, right? So this is fine. So we will keep only pairs where two displayed digits are different. So the only pairs accordingly with the question or the criteria will be going here, this sentence mainly, right? So we'll keep only pairs where two displayed digits are different, right? So this one we have pairs 0 comma 0, from and 0 comma 1 we have 0 comma 0 we have to consider, 0 comma 1 we have to consider, and 0 comma 2 also we have to consider, right? So then we will be going with 0 1 2, we have 0 comma 1, 0 comma 0 0 comma 1 0 comma 2, then we can go with 1 comma 0 1 comma 1 1 comma 2, these things, right? So in the case will be, it's similar to the intervals basically, right? So this is fine. Pairs we are going with 0 comma 0 0 comma 1 0 comma 2, 1 comma 0 1 comma 1 and 1 comma 2, right? So we have 0 comma 0, this is invalid because we have the duplicate 0, right? So again we have the duplicate 0 here, so this we will be considering this one as invalid, right? So this is invalid, we are not considering this one, right? 0 comma 1, yes, this is valid, right? So this is valid. 0 comma 2, yes, this is valid. 1 comma 0, again this is valid, right? So again this is valid, right? So 1 comma 1 is invalid here. We have duplicate of 1, so this one will be invalid, will not be considering 1 comma 1, right? So this is fine, and 1 comma 2 we will be considering this one, right? So this is valid basically, right? So what are the pairs we are considering here? 0 comma 1 0 comma 2, 1 comma 0 and 1 comma 2, right? Because we have from this one 0 1 2, 0 1 2, because 0 1 also we have 2 for this one, right? For considering 2 we have 0 1 2, so we can go with 0 comma 1 0 comma 2 1 comma 0, 0 comma, starting from 0 comma 0, sorry, 0 comma 0 0 comma 1 0 comma 2 1 comma 0 1 comma 1 and 1 comma 2, right? So here in this case we will not be considering the duplicates, right? So we will not be considering the duplicates within the pair. So 0 comma 0, so this 0 is the duplicate of 0, will not be considering this one, right? So this is fine. Same goes with 1 comma 1 as well, right? So duplicate of 1 is present within the pair, so will not be considering, we'll be considering these four: 0 comma 1 0 comma 2 1 comma 0 and 1 comma 2, right? So these four. So we need to return the count they have asked in the question, right? So we need to return the count pairs, right? So we need to count the pairs basically. We have got four pairs: 0 comma 1 0 comma 2 1 comma 0 and 1 comma 2, right? So this one we will be displaying in the form of output. So the output that we got here is 4. This we will return as output, right? So let's discuss the idea now. So as I have said, we will be going with the DP, right? Dynamic programming. So basically, DP idea used in the code will be digit DP over the combined length positions tracking, which base 7 digits 0, 6, this one 0, 6 are already used, means we'll be going with the bit mask basically. So this part you will get to know once we write the code, man, actually, right? And flags that indicate if har or minute prefix is already strictly less than limit, right? So this enforces basically hours less than or equal to n minus 1. And one more thing, minute less than or equal to m minus 1. This is accordingly with the question. We have already discussed this one, right? So hours has to be less than or equal to n minus 1, and minutes has to be less than or equal to m minus 1. So this one we have already discussed. And this one basically combined length positive tracking, which this one base 7 digits 0, 6 are already used because we'll be making use of the bit mask. So this part you will get to know when we write the code. Basically the idea that we will be making use of it along with the DP, that I'll be that let's discuss that one while writing the code itself, right? Rather than going with completely theoretical part. So I'll just the explain that one while we write the code itself, right? So count that we got here is 4. We know how we got 4 now, right? So this is the approach basically we'll be going, right? So this is the approach we will be going. What I showed, the calculation part, and that one I showed, that is the approach basically we'll be going in the term of in the math term basically, right? So that one we have to implement in the form of code. Basically this theoretical part I'll be explaining that one while we write the code itself, right? So here the output that we got here is 4, which is equivalent to the output that they have mentioned for the example 1 within the question, or input 1 within the question, right? So our approach works absolutely correct in this case, right? As we are completely familiar with the approach, let's do one thing. Let's discuss the complexities part very quickly, right? So what will be the time complexity here? The time complexity would lead to big O of 7 into length into 2 to the power of 7. When I say big O of 7 into 7 into length into 2 to the power of 7, uh, because we have up to length into 128 into 4, DP states, and this one we have up to length into 128 into 4 DP states, right? And we have to try at most 7 digits per state, right? So because they have mentioned base 7 but on the question, right? So I have stressed this one multiple times, right? So this one we have up to length into 128 into 4 DP states, again I'm telling this one, and we have to try at most 7 digits per state with length less than or equal to 7, right? So this is basically effectively constant. Overall time complexity would lead to pick of 7 into length into 2 to the power of 7, right? So overall time complexity would lead to big of 7 into length into 2 to the power of 7. This is fine. So what will be the space complexity here? Space complexity would lead to big O of this one length into 2 to the power of 7, right? So this is time complexity. Space complexity is length into 2 to the power of 7 for the DP memo table, right? So we will be going with the DP memo table plus big O of length for digit arrays, right? So big O of length for digit arrays, overall space complexity would lead to big O of length into 2 to the power of 7. Again we know that the small um, it is small since length is less than or equal to 7. Length has to be less than or equivalent to the 7 as per the constraint that they have given in the question. So this one we know, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of 7 into length into 2 to the power of 7 and big of length into 2 to the power of 7. I hope this part is completely clear, man. As we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. So yeah, let's start writing the code, right? So before that, usually uh, whenever we consider dynamic programming, right? So computing part will always be easy. Simple, it will be consisting of the simple math. Basically, we have to go with the simple math. Computing part will be easy. So how do we articulate in the form of code, and what we have to consider? That will be the main question, basically, right? Or if we are going with the data structure along with the DP accordingly with the constraint, that matters a lot accordingly with the question, especially when it comes to Codeforces, CodeChef, or the LeetCode these days, right? So after this one, people have started making use of the generative AI. So complexity of the problem has increased in the LeetCode as well, right? So problems are literally tough when it comes to lead code as well, especially the third one or the fourth one, usually the fourth one, right? So basically, whenever we are trying to implement the this one, what do we call, implement the solution, basically whatever we are trying to articulate in the form of code, the approach part and the computation part will be easy, right? It consists of the very basic math, right? I'm not gonna say no, but the same thing you have to articulate in the form of code, that will be somewhat tricky, and sometimes especially dynamic programming, every single problem will be different, it will not be same, right? So whether it may be knapsack, whether it may be anything, so it may be anything, right? I don't want to mention any one this thing, right? So these things also you have to know, bottom up approach as well as the top down approach, right? So whether you want to go with the recursion or you're okay with the iteration, iteration in the sense usually for the this one, what do we call, the better time complexity, right? For the this one, uh, if the constraints are extremely tight, usually you will go with the iteration part, right, rather than the recursion. Not for the time complexity, for the this one, uh, that should not cause MLE basically, right? And the for that purpose basically. So these are all the things that we need to keep in mind at any cost, right? So and every individual problem is different from one another when we are implementing DP, right? So they are not same at all. So that is one thing, and you have to know the topics, again I'm telling, top down bottom up approach and the different kinds of the problems that we solve basically, right? DP with the bit mask, right? Maybe it might be DP with bit mask, it might be DP with the trees, right? So there are many kind of problems that we can implement the DP with many data structures and for the different problems as well, right? So those things you'll understand once you start solving the problem, right? So that I wanted to say, explore more, the more you explore, you'll be good at it, right? So I'm not going to say that you'll be perfect, you'll never be perfect, even if you solve thousands lakhs of problems, you'll not be perfect, right? So I just want to tell you one thing: practice more, as much as possible, practice more, again, practice as much as possible, and don't practice the same this one, same kind of questions more. That's it. If you want to solve 10 to 15 problems, you solve it from the one topic, right? Then the most important topics are these things. So when it comes to competitive coding, the most important problems, after three problems, the fourth problem or the fifth problem in the code forces or the code shift, basically it consists of the DP, this one segment tree or the Fenwick tree or sparse table, and this thing, what do you call, graph. Basically these three topics you have to know for the interview point of view as well, for the this one, for solving the competitive coding problems as well, and for solving the this one lead code based problems as well, right? So these things you have to know. Suppose you can, in case you can leave the segment tree, but I insist you to go with the segment tree or the Fenwick tree and the sparse table, because if you are giving if you are doing the CP, quite obviously the problems will be based on, certain problems will be based on segment tree or the Fenwick tree, right? So you have to know that one at any cost. These topics, these three topics are very important, right? So again, DP, this one graph, as well as the segment tree, Fenwick tree or the sparse table, these things you have to know. Means you have to know different algorithms, right? So you have to know different algorithms and how do you implement it, and if there are any divisions within the same topic, that also we have to know, right? So these things you have to know. In the DP, I insist you to go explore the different topics, as well as you have to know two topics, one thing, two things within the DP. One is uh, this one, what do we call, bottom up approach as well as the top down approach, right? So these two things you have to know. And where do we use the recursion and where do we make use of the iteration, basically, right? And within the top down we make use of the recursion, I believe. Within the bottom up we make use of the iteration, so nothing but the DP table, right? So for the second one I'm speaking of, bottom up, right? So this one, second one is bottom up we make use of the iteration, and the top down we make use of the recursion, right? So it's better to go with the iteration part when it comes to memory management. So these are all the things that you need to know, again, right? So I'll leave you to explore, I'll leave you guys to explore. You have many resources currently in 2025, you have many resources that you can go through, right? Many websites as well, you have AI as well, right? So you have different AI tools as well, you can explore. this one, right? You can just explore anywhere of your choice, right? So that's left to you. So now let's come back to the problem. So here, mm let's start writing the code, man, accordingly with the approach, right? So first, what I'm going to do here, so we will be making use of the fast input and the output. For that, I'll just import input output Java input output package basically. So this is fine. We'll be making use of different utilities as well. This will be java dot util dot start. This is fine. Now let me go with the class, simple class. So this will be class main. You can just give any name that's relevant to the problem. I'll just give main here. I always consider main, right? So this is fine. Now let's do one thing. We have to go with the input. N and M were given in the input, right? So also, if you remember, while I explained the approach, I considered length h, length m, and along with the length, right? So we are considering, or we have to consider the lengths in the base 7. Nothing but length equals length h plus len m, right? So we need to initialize that one first. Again, accordingly with the question, we have to consider lengths in base 7, right? And length is nothing but it is equivalent to the len h plus len m, where I'm initializing, right? Currently, just keep this in mind. So this will be static, this one int n comma m, this one will be length h, this one will be len m, and this one will be length. This is fine. Next, let's consider the digits arrays. We have to consider digits arrays. Again, this has to be base 7 for n minus 1 and m minus 1 with the leading zeros. We have to consider digits arrays for n minus 1 and m minus 1 with leading zeros, right? Again, this has to be in the base 7. Just remember this one, right? So this one will be static int digit arrays. So I'll give the array here. So if you remember the approach, we went with digit digs n as well as the digs m, right? So this is fine, simple. Now we are going with a memoization table, right? So dp of position, mask, as well as the less h and less m will be going with. I'm speaking of the memoization table. For that we need dp. First let's initialize dp here. So again, what we need, dp of position, mask, less h, and this one, what do we call, less m. So 4 arrays we need here, right? So this one will be long, this is fine, this is fine, right? So we have 4 arrays here. Let me initialize dp. Again, position, mask, less h, and less m. This is fine. Now let's move on with the main method. So we are done with the initialization part. Let's move on with the main method. So I want to make use of exception here. Throws exception, right? So or else we can get the error. We might get error. So let's go with the fast reader first. So I'll just go with buffered reader PR. So this one will be equal to new buffered reader new. So we are going with the input, right? So this will be input stream reader. So this one is coming from system.n. So this is fine. Next, similar thing, we have to go for the output as well. For the output, we'll be making use of the print writer here. So, or let me do one thing. Let's not make use of anything currently. So I'll just go with the string for now. String input. So this one will be in. So buffered reader dot. So sorry, this has to be read line, man. This is fine. Read line. Oh, this one has to be split. So this is also fine. Yep. Now let's go with the n and m. Nothing but we have to parse n. N is nothing but the number of hours in a day. We know this one from the question. And we have to parse m as well. M is nothing but the number of minutes in an hour, right? So these things we have to parse n and m. So n, it is given in the form of integer. So we have to go with integer as usual, percent. So this one will be, we have to consider in of 0, right? So this is fine. Same thing, let me copy this one here for the m as well. Let me change the variable name, that's it. So this one will be, instead of n, I'll just go with the m. This is fine. Now what shall I do? We have successfully passed an and m. next what we need to do, let's go with the minimal places to represent max har. So we have to represent this one in the base 7, and also we have to go with the minimum places to represent the max minute as well in base 7, right? Both in the base 7, nothing but n minus 1 and m minus 1, right? So I'll just go with the len h accordingly with the approach we are articulating in the form of code, the same thing. So this one will be base 7 len, sorry, this one will be base 7 len of n minus 1. This is fine. Next, same thing, let me copy the same thing and make the necessary changes here. So this one, let me paste it over here. Instead of h, I'll just go for the m, as it represents the minutes, minimum places to represent max minute, right, in base 7. So this one also, this should be m instead of n. This is fine. Now let's move on with the further things. So we cannot have more than 7 distinct base 7 digits, right? So we should have only digits starting from 0 to 6, right? So when they say, when I'm saying base 7, right? So I'll just write the simple if condition here. If length h plus length m, this one minutes, if it is greater than 7, then we have to print 0. Means it is impossible to make all the digits distinct, right? In that case, we will be printing 0. So I'll just go with system out println here. Let me print 0. This is fine. And we don't have to return anything. I'll just give the return keyword here. This is fine. Let me come out of this one entirely. Next, what we will do, let's go with the length. Means here we, let's go with the total paces on the watch, right? So we have to go with the total paces on the watch, sorry. This one will be hours first, then minutes, right? Hours first, then minutes, sorry. I have to go with length equals len h. This one will be hours, then minutes, right? So I'll just concatenate minutes. So this one will be minutes. This is fine. Now we have to convert n minus 1 to base 7 array of the length len h. Also we have to do the same thing for the length m, nothing but the minutes, right? So we have to convert n minus 1 and m minus 1 to base 7 array of the length len h and length m, right? So this is maximum significant bit at index 0 for both, right? So how can we represent in the form of code? So this one will be, we have already considered digits n and m, if I remember. Yeah, let me consider digits n first. So this one will be to base, so this one, so to base 7 I have to give one. So this is fine. To base 7, this one will be n minus 1 comma len h. So this is fine. And also let me copy the same thing and make the necessary changes for the digits m. So let me come here, let me paste it over here. So D did I forgot here. So this one, let me make this one M, and also this one, instead of n minus 1, this will be m minus 1. Instead of the length h, this one will be length m. This is fine. Next, let's move on with the further things. Now we have to go from position 0 to length, and we have to mask 7 bits, right? So 7 bits, that is equivalent to 128, and less h is nothing but 0 or 1. It can consist of 0 or 1. Same goes with the less m as well. It can consist 0 or 1. Means in the sense here, position, mask, this one less h and less m are the things that we are going within the dp, right? So this one we are considering 4d dp array, right? So which consists of, in the beginning itself I have said, this consists of the position, mask, less h and less m, right? So less h and less m, you don't have to worry about that much about the naming, right? So when it comes to this thing, competitive coding, so here just remember we are going with a 4D DP array, right? So position, mask, less h and less m, right? So position from 0 to length, mask, we have to go with the 7 bits, nothing but 128, and less h, either it can be 0 or 1. Same goes with the less m as well, either it can be 0 or 1, right? So let me represent this one in the form of code now. So this one will be dp equals new. So this one will be long len plus 1. This is fine. 1 7, this is also fine. So this one will be 2 and this one will be 2 as well, right? So now let's iterate over the position dimension as well as let's iterate over the mask dimension, right? So nested for loops I have to write here. This one will be long. So this consists of the three values, right? So this has to be three arrays here. A, or this one has to be TP. This is fine. We are just iterating over the position dimension. Now we have to iterate over the mask dimension, right? So I'll just go with for again long. This is fine. Mm, this is fine as well. Now B of A basically. Sorry, this one, yeah, B of A. This is fine. Again, we are iterating over position mark dimension as well, position dimension, mask dimension as well, sorry. And we have to iterate over less h and less m dimension as well, which gives long of 2 basically, right? In simple terms, we have to iterate over less h bar less m dimension as well, right? Again, one more for loop here. This will be for long. This one is fine, C of B. This is fine, I guess, right? So now let's do one thing. Arrays dot fill of c comma minus 1. This is fine. Now we have initialized memo entries to minus 1, meaning it is not computed, right? So meaning it is not computed, right? This is fine, I believe, right? So final step is we have to start the DFS from this one, position 0, and also no digits will be used, not less than not less for both, right? So we see the this one DFS part first. Means let me make use of the helper method DFS, and then we can implement the same thing DFS here, right, within the main method, right? So I'll just come here. Let's do one thing. So we have to perform DFS, right? Just give me a second here. So let me do one thing. Yeah, I'll just come here. Let's make use of the helper method DFS quickly. So this will be static long DFS. So let me go with the parameters position, mask. Also let me go with less h. Also let me go with less m. So this is fine. So within the DFS method, so if we have reached the end, meaning we have to go with one valid assignment for the particular path, right? So if the position is equivalent to the length, then we have to return one in simple terms, right? So let me write that one in the form of code. So this one position, so I have to go with POS position. I have already considered in the parameter. So this one equals length. Then what we need to do, I return one. This is fine, man. Next, we have to go with the memo hit basically. So this one, let me write this one quickly. So this one will be dp of position, and this one mask. This is also fine. Sorry, do anything here. Why array within the array? So this one will be mask, and this one we have to consider less h less m, right? So less h. So this one will be less m, and also if it is not equal to minus 1, we are just going with a memo hit, right? So let's go with the return dp of position. This is fine. So this one will be mask, and again let's pass less h here along with the less m. This is fine. Yep. Now let's do one thing. Let's go with the accumulator for this state, meaning I'll just go with a, let me initialize result to 0. Now let's decide if the current digit belongs to har section or not. So let me go with boolean here in har. So this one will be equivalent to position less than len h. This is fine again. So again let me go with the limit this time. Limit because uh, if it is within in har, so I have to display this one. Yeah, let me consider digits of n of position, right? Else we have to go with digits m. We have to consider position minus len h basically, right? So len h. So this is fine, man. We are just limiting the digits for this particular position, right? So now for the for loop, let's try placing each base 7 digits, nothing but from 0 to 6, right, accordingly with the criteria or the question, right? So I'll just give here int d equals 0, d less than 7, and d plus plus. So this is fine. Now within this for loop, we have to skip if the digit d already used, if the digit d is already used somewhere, right? So this one will be fine. So this one will be if this is fine, mask is greater than d ampersand 1, this is fine, equal to 1, let me give continue here, this is fine. And so just give me a second here, let me go with one more if condition here. If in her, then this one line number 43, what we are doing here, basically we are just skipping if the digits d, if the digit d, sorry, already if it is already used somewhere, right? So if it is present, if in her, then we cannot exceed the limit, right, we cannot exceed the limit, then we can skip basically, right? So here I'll just write one more if condition here. So this one will be less h, this one equivalent to 0, and so d greater than limit. So this one, let me give continue here, this is fine. Now let's update the less h, means it becomes 1 if it is already less, or if the current digit d is less than limit. So I'll just go with result equals result plus. So let's make use of the DFS. We are going with a recursive DFS, right? So this one will be position plus 1 comma mask, or I'll just go with here 1. So left shift operator d, this is fine. Again we have to go with a less h, right? So this is fine, just give me a second here, or d less than limit 1, this is fine, 0, this is fine, I'll just go with less than, yep. So this will be else basically. So within the else, what I'll give, let me write the simple if condition here. Means we have to go with the same check for the minute section as well. We went with the har section. Now we have to go with the minute section basically. See here, we are going with the har section, right? Let's h equals 0. So the same thing. I can copy paste and make the necessary changes. But let's do the same thing, man. So here, else we have to go with the minute section, right? So let me paste it over here. Instead of if let's say, I'll just keep here less m. So this is equivalent to m, and yeah, d greater than limit. So then we have to continue, means same check for the minute section as well, right? So then we have to update the less m similarly. Less h will be unchanged in this case. So this one will be result plus dfs of position plus 1 remains same. Mask of this one, same thing, or 1 left shift operator d, so this remains same. So here along with the less h, this remains unchanged, less h remains unchanged. So we will be adding less m as well, as we are dealing with the this one minute section, right? So this one will be less m, or d less than limit, same thing, we have to display 1, else we'll be going with a 0, right? So we don't have to mention less m, we have already mentioned this one here. So this is fine. We are done with the minute section as well. Let me come out of this one entirely. Let me do one thing. Let's store this one in the memo and return, or in simple terms, we'll be caching this one and let's return, right? So I'll just give here return. We are storing in the memo, or we are caching, right? So I'll just go with dp of position here. This one will be mask, this is fine. This one will be less h, so this is h. And finally, let me go with the lesson minutes as well. So this one, let me assign this one to the result, right? So let me assign this one to the result, nothing but we are storing in the memo, or we are caching and just returning in simple terms, right? So now this is fine. Let me come out of this one entirely. We are done with the dfs helper method, right? So now after we have, after finishing the DFS method, helper method, DFS method, let's make use of it. Let's make use of it within the this one. What do we call main method, right? So I'll just go with system out println here. So we have to start the DFS from positions, well, from the position 0, right? So no digits being used and not less for both, right? So 4 times 0, 4 arrays we have. I'll just give here in this case 0 comma 0 comma 0 comma 0, right? So this is fine, easy, right? So we are done with this part. So now we are left with this one. What do you call, just give me a second here. We went with the DFS, right? So now we have to go with the base 7 length as well as the 2 base 7. So here we have made use of 2 base 7. So here I have directly made use of the helper method 2 base 7, right? So I haven't written the helper method yet. So for this one as well, I thought you'll be knowing about the base 7, so that is the reason I have written this one directly. But we have to implement this one, right, first within the helper method, then we have to make use of it, right? So I have made here, this is not any this one, any this one data structure operation or this thing we are writing here directly. So this is the helper method, I have directly made use of it, and 2 base 7 and this one base 7 then basically, and we have to write that helper method, and then it will be correct basically, then we have to make use of it. So first only I have written, I sorry, I forgot to mention this one basically. Now let's write the same. We are left with only two things. One is we have to write the base 7 len method as well as the 2 base 7 method. First let's write the base 7 length method. Basically what it does, it returns number of the base 7 digits that is needed to represent x. Means x has to be always greater than or equal to 0. This we know this from the constraint as well, and we know this from the question as well. So we have to go with the convention that 0 requires one digit, right? So always remember, we have to go with the convention that 0 always requires one digit. Means when x is equivalent to 0, we have to return 1. In the terms of coding, if x is 0, then we have to return 1, right? So that's what I wanted to say. So I'll just go with static here, int. So this one will be base 7, and so this one I have already made use of it within the main method. So let me go with the int x. This is fine. So within this method, as I've said, if the value of x is 0, then we have to return 1. And 0 is represented as single 0 digit. Always remember this one, right? So now this is fine. Let me initialize L equals 0 while uh, x is greater than 0. Then let's do one thing. Uh, Let me increment this one. Also, let me go with x equals x by 7. So this is fine. This is also fine, right? So we are counting the digits by dividing it by 7, right? So this we know because we have to go with the base 11, base 7 length, right? So this is fine. Finally, let's return L. So I'll just return L here. So this is it for this helper method, right? So we are left with the last helper method, nothing but 2 base 7. Means we have to convert the integer x, which is quite obviously greater than or equal to 0, to the base 7, right? So we have to convert the integer x to base 7 digit array of length len, right? So most significant digit at index 0 fills with leading zeros if needed, right? So just remember this one. Just remember one thing, that we will be converting x to base 7 digit array of length alien, right? So just I'll just go with the method to base 7 here. This is fine. Let me go with the parameters x and len. This is also fine, man. Yeah. So now let's allocate the result array. So I'll just go with result equals new int of, so this one will be len, man. This is also fine. Now let me go with the iteration part. Nothing but we have to fill from the least significant to most, right? So I'll just go with for int I equals len minus 1. So I greater than or equal to 0, I minus minus. So this is fine. So now we have to fill from the least significant this one to the most, right? So within the for loop, let's go with the current digit first. So this one will be iterated value of the result. This one will be x modulo 7. We are going with the current digit. Also, next, as I've said, what we are doing in the for loop, basically we are filling from least significant this one to the most, right? So we have to shift right in base 7. This will be x equals x by 7, right? So I'll just go with uh, x equals x by 7 basically. Right here, let me leave the space here as well. X equals x by 7. So we are almost done with the coding part. One thing we are left with here is we have to return the filled array. Means we have to go with the leading zeros, that is included if x was small, right? So this is also fine. So now it has to be we have to return this one. What do we call? Result. Let me return a result here, right? So this is fine, I guess. So somewhere I have done something wrong, man. I don't know what's wrong, but somewhere I have done something wrong. So yeah, this one I have misplaced one bracket here. This one has to be here basically. Sorry. Yeah, this is fine, man. Now before checking, we are done with the coding part. So this is it. We have went with the two base as well as the base sum and then methods, helper methods, and also we are performing the DFS as well, right? As I have said. So this is pure dynamic programming. This one we are going with a 4D DPRA, right? So as I've said, this one, what do we call? Position, mask, less h, and less m. We know this one, right? Fine. In the final step, we are storing that one in the memo and we are returning, if you remember. So this one, not this one. Where is it? Uh, Not even this one, man. Base 7. This one within the actually. Oh, I have missed. What do we call? Semicolon. This would have given the error. This is fine. So now, before checking the code with different inputs, let me copy paste the signature starter template. Just give me a second here. So now let me, so I misspelled the import here as well. So this one will be, this is fine. Now let's concentrate on the logical part. Let me copy this one, let me come here, let me paste this one, let me run this one. So we are getting the error, right? So missing return statement, line number 82, line number 82, 82. So we are return, oh my bad, man. So we are returning the, just give me a second, x equals x by 7. Yeah, we have to keep this here, I guess. That is the reason we are getting this one again, misplacing the bracket. So let me return this one again. So yeah, we are getting the output 2 here, right? So the output that we need to get here is 4, man. So we are getting the wrong output, right? So let's check what we have done wrong. So let me copy this input as well. Let's see what output we are getting here. So we are getting 0. We need to get the output 5 basically. Let's check what we have done wrong. So what mistake I have done here is, so we have set, we have written m. I have copy pasted this one. I forgot to change this one here, right? So I just changed the variable, but here we have to go with the n and m, right? So this one, n and m, this one we have to go with 0 and 1, right? So this is fine. We are just going with the same this one n value of the n itself for the m as well, right? So this will obviously give us the wrong output. Now this is the only change I need, I believe. I don't know. Let's check, man. So let me go with the first input here. So yeah, now we are getting the output 4, which is absolutely correct, right? So this is fine. Now let me copy this. We have to get the output 5. Let's check. So yeah, we are getting the output 5. Perfect. Right, so now we are done with the coding part, right? So we are getting the desired output as well for the inputs they have mentioned in the question. Now let me do one thing. Let me copy the entire code. Let me come here to the question. Let me hit the submit button. uh, Let me paste the code over here. Let me hit the submit button again, man. So we are done with the coding part, right? So we are done with the submission part as well. Let's wait for some time, man. I hope this works for all the test cases, right? So let's see. So here you can clearly see, right? Uh, in the toast it is showing accepted, also in the verdict this is showing accepted, this is fine. So now again we have went with a pure DP along with the DFS, right? So 4D DP array we have went with basically position again, position, see here, mask, less h and less m. And I hope the approach part is completely clear as well, man, because whatever we have implemented in the approach, we have articulated the same thing in the form of code, right? We have articulated same thing in the form of code, right? So that's what we did. Basically we made use of the three helper methods, basically one for performing the DFS, and the second one we have went with base 7 length, and this one to compute or to convert to the base 7 we have went with the to base 7, right? So helper method, these three helper methods along with the this one DP, right? So we went with the DP memo table as well, right? So this is fine. Now we are done with the solution part, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.